Welcome back everyone to the next lecture on your ratio scale, right? Last lecture we learned about interval scale. Let me just recap what we learned. We learned your nominal, right? We learned nominal scale, then we learned ordinal, right? Then we learned your interval scale, right? Now let's move on to your ratio scale. Now the ratio scale is very important for us, all right? It's very important. So it is one of the most powerful levels of measurement in your biostatistics. So in the next, in this video, we're going to see about how it makes it more unique, explore its features, and we are what examples for the same. Now, what is the ratio scale? The ratio scale highest, is the highest and the most important and informative scale. All right. It has the following features. First feature is what? It First feature is that it has equal intervals between the values. Second point is that it has a true 0 point. It means what? Over here, the zeros have meaning, right? That means what? If I say something zero means it lacks. For example, when I say a weight of 0 kg means what? That means there is no weight, right? There is no weight at all. So this will make me to say what? 4 kg is twice as heavy as 2 kg, or 4 kg is 4 times heavy as heavy as 1 kg, right? So over here, ratios do make sense. In the last video, we learned that in your interval scale, the ratios do not make sense. But in this ratio scale, you have your ratios making sense. And even difference also making sense. I can also say what? The difference between 3 minus 2 kg is same as 2 minus 1 kg, right? It's equal to 1, right? The difference also makes sense. So where can we use this in biostats? Where can we see this in your biostatistics? First is what? First is your height and weight, right? Height and weight. Second is your blood pressure, right? Third is time measurements. This list is not exhaustive. You can add more and more, right? You can add your more and more to this list. This is just an example of I'm giving to you all. Okay, these examples demonstrate how the ratio scale enables meaningful comparison and in-depth analysis in your biostatistics. Now, what are the advantages of it? Over here, I can perform all meaningful mathematical operations. That means what? When you add, subtract, divide, or multiply, everything makes sense in this scale. All right. If you do this in other scale, it will not make sense. It has meaningful ratios. I can see what? I can see something is twice as heavy. I can, if I carry 10 kg dumbbell means, I can see that this 10 kg dumbbell is heavier, twice heavier than 5 kg dumbbell, or 10 times heavier than the 1 kg dumbbell, right? So over here, ratios do make sense in this scenario. All right. With this ratio scale, we are able to do a lot of statistical and mathematical operations, which you will see in the coming units. For now, this is good for you all to know. So to summarize it, the ratio scale is indispensable in biostats because it provides the most precise and meaningful measurements. Its true zero points and ability to support all statistical operations makes it a cornerstone of data analysis in healthcare and biomedical research. So that's all for scales of measurement. We learned your nominal scale, which has no order. Alright, it just names. Ordinal scale, you have orders, but you can't exactly find the difference between those two, right? In ordinal scale, you can't say that twice, or suppose you do 2 stars or 1 star, you can't say I'm twice satisfied as 1 star, right? That's your ordinal scale. Next, you have an interval scale, which is your temperature so and so. It has no true zero point over there. And next, your ratio scale, where it has a true zero point, and there are also meaningful, meaningful difference also between those two. So you have your ordinal, nominal, interval, and ratio. All right. So that's all in scales of measurement. Let's see you in the next unit, next topic. Sorry. Thank you and have a nice day.